Hello, algebra students. Welcome back to another video on logarithms. So today we're just going to check out solving logarithm and exponential equations. So let's do solving exponential equations level 1. Let's hop right into it. So we're solving for x, rounding to the nearest hundredth. So what we're going to do before we take the screen cap, and now we're going to see that e raised to the value x over 4 equals 7. Now we know that we can get rid of something from an exponent into normal land by taking a log with base equal to the thing being raised to that power. So log base e, which is better known as natural log of e to the x over 4. So let me go ahead and write that out. Natural log of e to the x over 4 equals, have to do the same thing on both sides, natural log of 7. So now we can see that the natural log, since it's log base e, cancels with e, and we get x over 4 equals natural log of 7. So now let's simply multiply both sides by 4. So x equals 4 natural log of 7. Let's go ahead and punch that into a calculator. We could rearrange that as natural log of 7 to the 4th, but since they're all numbers, we don't really need to do any more condensing or rearranging. We just want to solve for x by plugging it in. We're going to say 4 natural log 7. And the value we get is 7.78 some other stuff. Nearest hundredth is going to be 2 decimal places, so 7.78, because 3, which is the next place, is smaller than 5. So we round down. Sweet. Let's try one more of these and then move on to the next one. 2 times 3 raised to the x over 5 equals 1. So let's go ahead and rearrange that equation. We're going to go ahead and start by dividing both sides in half. So these guys will cancel, and we're left with 3 to the x over 5 equals 1/2. So we're going to have to, again, take a log on both sides in order to balance this. So we get log base 3 of 3 to the x over 5 equals log base 3 of 1/2. So the 3 and the log base 3 part cancel on the left, and we're left with x over 5 is log base 3 of 1/2. So let's multiply both sides by 5 to get rid of that over 5 on the left. So x equals 5 log base 3 of 1/2. So now we can go ahead and rearrange a couple of things. To get log base 3 of 1/2, you can divide log of 1/2 by log of 3. So that's going to be the same thing as, because calculators don't always give us the option of putting a number down here, but an equivalent statement would be 5 log with any base of 1/2 divided by log, so long as it has the same base, of 3. Now let's go ahead and plug that into a calculator. 5 log 1/2 over log 3. Let me fix that, making sure it's just 1/2 divided by log 3. We get negative 3.15, and the 4 rounds down. And we know it's got to be negative because it's turning, let's see, where do we start? It is turning 3 into 1/2. So let's go ahead and move on to the next section. So we're solving for x to the nearest 10th here. Now the numbers here are pretty messy, but that doesn't make the problem any harder. That's simply here to show us that the problem doesn't depend on the numbers being convenient looking. So let's go ahead and take another screenshot and get to work. So let's go ahead and divide both sides by 610. It's kind of a bystander here. It's not a part of the main deal. So we've got 47 over 610 is this nonsense over 610. So this cancels, and we're left with 0.5 to the x over 4 equals 47 over 610. Now let's see what we can do to simplify that a little bit. We're going to need to take the log base 1/2 of both sides. So log base 1/2, because 0.5 is 1/2. Log base 1/2 over here as well. And we know that this will cancel with that, so we've got x over 4 equals that nonsense. So x, multiply both sides by 4, equals 4 log base 1/2, or base 0.5, same difference, of 47 over 610. So now what we're going to do is simply, like we've done a moment ago, that is going to be the same as 4 log 47 over 610 divided by log 1/2. Let's throw that in a calculator and see what we get. 4 log 47 over 610 divided by log 1/2. We get 14.79. We're running to the nearest 10th. That'll be 1 decimal place. But since 9 is more than 5 and it's the next digit, we're going to round up to 14.8. Sweet. So let's try one more like this and move on to the next bit. 13 equals 9 times 2 to the 0.03x. So we're going to start this the same way we always do. Zoom in. Let's cancel out that extra factor, which is the 9. So we're going to get 13 over 9 equals 2 to the 0.03x. So the way we're going to do that is, again, take the log base 2 of both sides, cancel it on the right, and we end up with 0.03x is log base 2 of 13 over 9. So log base 2 of 13 over 9 divided by 0.03, which is going to end up multiplying by 30 and change, is going to be equal to x. So again, on a calculator, we'll do log this divided by log that. So that's going to be equal to log of, this is where you got to make sure you're using parentheses well, 13/9 divided by 0.03 log of 2. And that's equal to x. Log 13/9 divided by 0.03 log 2. 17.68. Nearest tenth is going to be 17.7. Nailed it. So these numbers are going to be terrible. But so long as we know how to rearrange these problems, we're going to be just fine whenever we go to solve them. It's easy. How about logarithmic form? We've been doing exponential equations. Now we're doing some log equations. Let's go ahead and say log base what of 729 is 6. So that means what number do we have to raise to the 6th power in order to get 729? So that question simply says, what is 729 to the 1/6 power? So it's the number you're going to have to raise to the 6th power. We have another way of writing it, and it looks like this, except we want the one that has the letter n over the check mark, because that means we can have any root that we want. And we want that root to be a 6th root of 729. And our answer is 3. Because 3 to the 6th power is 729. Now, it asks for a positive value of x. The reason it has to say that is because if you took -3 to the 6th power, since the negatives would cancel because you're raising it to an even power, you'd still get 729. But that's not what they're looking for. What they want is the 6th root of 729. So let's go ahead and try another one like this. Log base 4 of x equals 2. So right here, the log gives you the exponent, meaning if it's missing inside the parentheses, you raise 4 to the 2nd power, and we get 16. Log base 4 of 16 is 2. We'll do one or two more of these just to continue. Now log base x of 125 is 3. That means we want the 3rd root of 125, which is 5. Another way we could do that is if we just raised 125 to the 1/3 power. We will get the same result either way. So we can say that 5 is confidently say that 5 is our answer. So again, whenever we're missing what's inside the parentheses, we raise the base to the power on the right side. So 2 to the 5th is 32. So let's go ahead and move on to our final section of the video right here. So solve the following logarithm problem for the positive solution for x. Log base 512 of x is -2/3. So again, when it's missing inside the argument of the log, which this one is, we take 512 and raise it to the, make sure you use parentheses, -2/3 power. And we're going to say 0.015625. Now, there's a chance that it won't like this answer. No, it does. It says it's 1 divided by 64, and 0.015625 is 1 divided by 64. I just wanted to preface that in case it cared about the formatting more. But this is actually good news because that means we can do it with a calculator and give it the answer directly from the output. Let's go and do another one or two of these. Log base 49 of x is 1/2. So if we have the base and we have the answer, we'll do 49, which is the base, raised to the, use parentheses in case something goes weird with the formatting, 1/2, which is the answer, we get 7. Perfect. Now, here, this is what I was looking for. Log base x of 216 is 3/2. So the way we're going to do this is just like we did a moment ago. We want to take the 3/2 root of 216, or we could flip the fraction and do 216 raised to the 2/3, because that's 3/2, but inverted. So our answer is 36. You have to flip that fraction in order to get back. So this is pretty much all that I wanted to cover today in this video. I hope that it really helps you out. As long as you're paying attention, you should really nail this. Be sure to come and find me if you have any questions. Have a good one. I'll see you in the next one.